it's a blue sheep. Welcome back to our classroom. Today, I'll be teaching you about how to calculate with moles. What is a mole? In our world, atoms such as hydrogen, molecules such as water, and other tiny particles such as electrons are collectively called particles. And 1 mole is defined as a mass of 6.02 times 10 to the power of 23 of these particles. For example, when you buy eggs, you probably buy a box of 12 eggs. These 12 eggs are calculated as 1 dozen in a box. A dozen is 12 of something. It's the same in the world of particles, where counting each individual particle is extremely difficult because they're very, very small. So the enormous number of 6.02 times 10 to the power of 23 particles is lumped together and defined as 1 mole. The quantity of 6.02 times 10 to the power of 23 itself only exists as a definition. So you should just remember that it exists and know that that's how it is. It's just how it is. The number 6.02 times 10 to the power of 23 is called Avogadro's number, not avocado. Why 6.02 times 10 to the power of 23? It's so random. But this is determined so that when a certain number of atoms are gathered together, their mass will exactly match the mass number of these atoms. Also, 1 mole can be 6.02 times 10 to the power of 23 atoms of any type, such as hydrogen or carbon. Or it can be 6.02 times 10 to the power of 23 molecules of water, and more. When calculating with moles, you need to know the relative atomic mass of all the atoms in the molecule. Get the relative atomic mass from the element on the periodic table. The number on the element that is larger is the relative atomic mass. In the case of hydrogen, it will be the same. For example, for oxygen, the relative atomic mass is 16. In the case of O2, there are 2 oxygen atoms, so 16 times 2 is 32. What does the 32 mean, though? This represents the weight in grams for 1 mole of O2. Basically, 1 mole of O2 weighs 32 grams. The molecular weight of a water molecule, H2O, is 1 times 2 plus 16, which is 18. This 18 means that if there is 1 mole of water, that water weighs 18 grams. In other words, water has a mass of 18 grams per mole. Once you know the number of moles, you can find out the weight. Now, I'll give you a few questions to test how well you understood. Number 1. How many grams are in 1 mole of hydrogen molecules? A hydrogen molecule is H2. The atomic weight of H is 1, so the molecular weight of H2 is 2. Therefore, 1 mole of hydrogen molecules weighs 2 grams. Question 2. How many moles of nitrogen molecules are there in 0.28 grams? The atomic weight of nitrogen, N, is 14. The answer is the molecular weight of nitrogen molecule, N2, is 14 times 2, which is 28. In other words, 1 mole of nitrogen molecule weighs 28 grams. So 0.28 grams of nitrogen molecules is 0.01 mole because it's 0.28 grams divided by 28, which is 0.01. The mole unit has 4 functions. 1 is molar mass, grams per mole, molar volume, liters per mole, molar concentration, mole per liters, and mass molarity, mole per kilograms. Molar mass, which is grams per mole, is called the molar mass, and it's the atomic weight, molecular weight, and formula weight, with grams per mole added. For example, let's take sodium chloride, NaCl. We can see from the periodic table that the atomic weight of Na and Cl are 23 and 35.5. So the formula weight of NaCl is 23 plus 35.5, or 58.5. This formula weight, 58.5, is the mass per mole. In units, it is 58.5 grams per mole. If you have 5 moles of NaCl, you can see that it weighs 58.5 grams per mole times 5, which is 292.5 grams. On the other hand, if we know that 107 grams of NaCl was produced after sodium, Na, and chlorine, Cl, reacted, we can also know that 2 moles of NaCl were produced, since 107 grams divided by 58.5 grams is 2 moles. The second unit used in mole is molar volume. Molar volume means under standard conditions of 0 degrees Celsius and 1 atmosphere, the volume of 1 mole is 22.4 liters. This means that regardless of the type of molecule, 1 mole of gas at standard conditions will be 22.4 liters. Now, I'll give you a few questions to test how well you understood. Question 3. How many liters is 1 mole of hydrogen molecule at standard conditions? The answer is 1 mole times 22.4, which is 22.4 liters. And that is it for today's video. Please like and subscribe if you learned something new. 3, 2, 1, me!